Hello friends, this video on Communication Systems Part 17 is brought to you by examfear.com. No more fear from exam. So now the question is, okay fine, the amplitude modulated wave is produced. That we understood. Now the question is, how is this amplitude modulated wave transmitted? Because after all, why are we producing this wave? Because this kind of wave will be easier to transmit, right? This modulation itself, why are we doing it? Because we want to make a wave which is easier for transmission. So a higher frequency wave is easier for transmission, and an amplitude modulated wave is one of that kind. So let us see how will this wave get transmitted. So far it is clear. So we have this message signal. It is made to pass through amplitude modulator. Now what is there inside amplitude modulator? I just discussed in the previous slide. So that entire package together is known as amplitude modulator. So out of that amplitude modulator will come the amplitude modulated wave. This wave is made to pass through a power amplifier. So what will that power amplifier do? It will amplify the signals. So here we have two new terms. Till here we have discussed, right, in the previous slide. So what is a power amplifier? It provides the necessary power for transmission, because as I said before also, for an effective transmission, the power radiated should be more. So if there is more power, the transmission will be more effective. So how do you increase that power? For that we have power amplifier. The word amplifier, it amplifies everything, increases everything. So we want to increase power, we use a power amplifier, right? So now once you have this power amplifier, now you have both the things. You have a signal which is amplitude modulated. That means a high frequency signal. At the same time, you have the power amplified. So you have both the things good for transmission. And then what do you need? You need an antenna. Why? Because for transmission, you are not going to transmit the electrical signals directly. Those electrical signals need to be converted into radio waves, because the radio waves will propagate through the medium. So you need an antenna. And that antenna is known as the transmitting antenna. Right? So now you understood the entire process. So everything starts with the message signal. Then the message signal, so quickly I'll have a recap. Message signal, it will combine with the carrier wave. It will form some wave which will go into the square law device. The square law device will produce an output which is made to pass through the band pass filter. So filter will reject out all unwanted components, and the result which it will give will be an amplitude modulated wave. Then it is passed through a power amplifier so that the power can be increased, so that it becomes even better for transmission. Then it is passed through the transmitting antenna, which will convert this electrical signal into radio waves, and those radio waves will be propagated through the channel. Clear? So this idea till here should be clear, how the amplitude wave gets transmitted. Now the transmission part is clear, the wave got transmitted. So which part is left? How will the wave be detected, or how will the wave be received by the receiver end? So now we will talk about the receiver end. So let us have a look at the receiver end as well. So far we talked about the transmitter end. Now this transmitting antenna will give radio waves which will propagate through the medium. Now where will this radio wave go? It will go towards the receiver. So what should we have at the receiver end which can actually detect this radio waves? Right, a receiving antenna again, because receiving antenna is the one which can convert these waves into electrical signals again. Right? So it will convert the radio waves into electric power again, and those signals will again be passed through an amplifier. Why do we need an amplifier here again? Because since the waves propagated through such a long distance, there might be some kind of attenuation, right? So in order to overcome that, we have an amplifier so that it can amplify the signal. After that, we have an IF stage, that is intermediate frequency stage. So what happens at this intermediate frequency stage? We will see that. So from there it will go to the detector, which will actually detect the signals which are necessary in that wave. It will again go to the amplifier to keep it amplified, and then it will give the output, right? So this detector is the one which will actually choose the message out of that signal. Like right now it is an amplitude modulated wave. That means your information, that is the message signal, is hidden inside the carrier wave. So this detector will take out the message signal out of that carrier wave. So it doesn't need the carrier wave. Carrier wave's purpose was just to carry the information. So the detector will snatch out the information and leave the carrier wave as it is, right? So this is how the transmission actually happens. So I think this slide is the most important slide, which actually tells you how exactly the communication system works. So once you are clear with this idea, I'm sure that you are clear with the idea of a communication system. So now some of the things which we will discuss now is the receiver. So there are different components in the receiver end as well. So let us quickly look at these components which together form the receiver end of the communication system. So as I said, the first thing has to be a receiving antenna, right? Because the signal which is actually coming through the channel is not an electrical signal. It is basically the radio waves. So you need something which is going to convert those radio waves into electrical signals. And who can do that? None other than the antenna. So you need a receiving antenna which will convert the signal, which will convert the radio waves into the signals. Now this received signal then goes into the amplifier. So it goes into this amplifier. What will this do? This will amplify the signal to compensate for the attenuation. As I said, since the waves have been traveling over a large distance, there are chances that it might have got attenuated. So its amplitude would have got reduced. So in order to compensate for that, we have an amplifier here which can increase its amplitude. The next is the intermediate frequency stage. So here let's see what it is. This frequency stage will lower the carrier frequency to an intermediate value. Now, the carrier wave, they were recognized by their high frequencies. But why we needed that high frequency? Because that high frequency helps in transmission. Now, once it has come to the receiver end, now we do not need that high frequency, right? So this intermediate frequency stage will lower the frequency of the carrier wave to an intermediate value. Then comes the detector, which will snatch away the original message signal from the modulated wave. So as I said, this was your modulated wave. So the modulated wave looked somewhat like this. But what is my message signal? The message signal looks somewhat like this. So this detector will actually snatch away this part from this modulated wave. Right? Okay. So let us now talk about the detection part in detail, that how exactly this detector functions. It helps in recovering the modulating signal from the modulated carrier wave. As I mentioned just now, the modulated carrier wave contains the hidden message signal, but that message signal is the one which is all about communication. It is because of that message signal that we are studying this entire lesson on communication, right? So now if we get back to our old example of letters. So when you send a letter to your friend, the letter reaches the post office. Now, when it reaches the post office of Bangalore, it doesn't reach as a single letter. There are a bunch of letters inside a big box. But do you think that entire big box will be dispatched to your friend? No. Only the letter which is intended for your friend will be taken out of that box and will be delivered to your friend. So that is nothing but detection. That means only the intended signal or only the message signal will be taken out of the carrier wave and it will be sent to the receiver end. That means it will be sent to the destined user. So here we can see how it actually functions. So this is the amplitude modulated wave, right? Now this is made to pass through a rectifier. What is a rectifier? It is a device whose output is unidirectional. For example, if you have a wave like this, so this is a bidirectional wave. When you pass it through a rectifier, what is the type of output that you get? Somewhat like this, if it is a full wave rectifier, and if it is a half wave rectifier, then you would get somewhat like this. So we have spoken about rectifier in our lesson on semiconductors, right? So by now we know what exactly is a rectifier. So now when this amplitude modulated wave is passed through the rectifier, so again it will give unidirectional output, so only the positives will remain. So the negatives will go off, and that is why we say unidirectional, that is only one direction. And then it is passed through another device which is known as the envelope detector. So what will this detector do? This will only recognize the envelope. And what is this envelope? This envelope is nothing but the original signal, because whatever is present inside is the high frequency wave, and high frequency wave is the carrier wave. And what forms the envelope is nothing but the modulating wave or the original message signal. So our aim in this process of detection is to detect the envelope of this modulated wave. So this is how detection is done. So the detector consists of a rectifier and an envelope detector, right? Now what is this rectifier? It is a device that converts AC into DC, that is bidirectional current, into unidirectional current. And what is envelope detector? It is an RC circuit. I mean, if you want to know what kind of circuit will this envelope detector have, it will have a resistance capacitance circuit. So somewhat like this. You have a diode here, you have a capacitor, and you have a resistance in parallel to this capacitor. So this is resistance, this is capacitor. On this side, you apply the input, and here you get the output. So this is how the circuit, RC circuit of an envelope detector looks like. Thank you. Please visit www.examfear.com to watch more videos, attempt free online test, get free study material, find tutors and mentors. Thank you once again.